First thing we need to do is write all the givens. Hopefully they wrote that on their sheet. But the givens are mu is 7. The alternative mu is not, is less than 7. That makes it a one-sided test. I told you alpha was 0.01. Sigma was 0.5. N was 30. And then later on, the alternative hypothesis I'm going to test is that it was 6.5. So far, so good. Next thing I need to do is draw a picture. Hopefully you got a picture drawn okay. So I'll draw it pink. In the middle of the picture, I put the HO, the hypothesized mu, which is 7. Then I can also draw in things like the standard deviation, 0.5 over the root of 30. And my alpha level and my fence go here on the left side. Why do they go on the left? Less than test. Good. Next thing, take that 0.01 and look it up on your pink chart or inverse norm it to find the z that goes with that is negative 2.326. So the rejection region in terms of z is to get something that's less than that. I should probably write up here. Here I'm going to fail to reject HO. And over here I'm going to reject HO. It's very difficult to write with this thing, clearly. But that says reject HO. All right, next thing I need to do is take that number that we got and unstandardize it to find the x bar. So I'm going to work that up here at the top so I have some room. Negative 2.326 is x bar minus 7 over 0.5 divided by the square root of 30. When you solve that out, you get 6.7876. So that is my cutoff point in terms of x. So my rejection region in terms of x is getting an x bar less than 6.788. Right? Okay, so the next thing I need to do is address this new true blue mu. Draw that on this picture I've got. 6.5 is to the left of 6.788. So here is 6.5. Beta is the probability of making a type 2 error. A type 2 error is when I keep believing HO, but I should have rejected it. That's this area right here. This stuff is beta. That's beta. So beta is the probability that I get an x bar greater than 6.788. When you standardize that, you standardize it according to the new true blue mu. 6.788 minus 6.5 5 over 0.5 divided by the square root of 30. Work all that dude out. That's the probability you get a z greater than 3.15, which is 0.000814. That's beta, the probability of a type 2 error. Power then is 1 minus beta, so it's 0.9992. Power is rejecting HO when some alternative like 6.5 is true. In this case, all this area to the left of my green fence represent power. To interpret power, you would say if the true mu is 6.5 and I take a sample of 30, whatever these are, there's a 99.9% chance I'll get an X bar less than 6.788, less than or equal to 6.788, that will tell me to reject HO. Mu is 7. That's a good thing. I want to reject HO, mu is 7, if the truth is 6.5. That's what power is. Let me say that one more time. If I thought that mu was 7, but in reality it's 6.5, and I take a sample of 30 things, there's a 99.9% chance that those 30 things will have a sample mean, an X bar, less than 6.788, telling me to correctly reject HO. That's what power means.